Welcome to Maths for You channel. Another past question on statistics. Temperature in a certain city was recorded daily for 20 days. For this set of data, the mean mu and the standard deviation sigma were calculated as 28 degrees C and 4 degrees C respectively. However, after detecting that two of the above temperatures have been mistakenly entered as 35 degrees C and 21 degrees C, they were later corrected as 25 degrees C and 31 degrees C. Find the correct values of mu and sigma, or standard deviation. Okay, the sample data, the number in a sample data, number of sample data, I just took it as n, it is 20, n equal 20. The mean of those 20 values every day, they recorded temperature, at 28C, the average or mean. And the standard deviation sigma is 4 degrees C. So the data collected. So just for in a common term, I just put xi. I is 1 to 20. So x1 is first day, x2 second day, and so on. So this one, sigma, it's xi, I equal 1 to 20. So that gives you the total, the value recorded within that during the 20 days, 1 to 20. So it's 1 to 20 is x1 plus x2 plus x3 and so on up to x20. That's the total value, the total of 20 days temperature. So the total and divide by the number of days, it gives you the mean. So mu equal sigma I 1 to 20 xi, that is the total 20 days temperature, divided by n, gives you mu. So the mu we know, and n we know 20 days, so we can actually get the total. The total is it's 560, so 20 days. The collected data temperature every day, add them together, is 560 degrees C or 560. But they says the two days values is incorrect. The first time they actually did that, and they calculate the mean value and the standard deviation. But the two of those data incorrectly entered. There were 24 and 21. There could be, say, X5 and X7 or whichever. In that 20 days, 2 days the data, 2 days temperature were 35 and 21. They recorded, but there were 25 and 31. Yeah, okay, 25 and 31. So the total that 35 and 21 were incorrectly recorded or incorrect values is 456. And the correct value of 24 and 31, again, total 56. So the grand total would in a change. So the total is still 560, even though there is two errors. But the total, the two errors and the two temperature add together 56, and the corrected temperature add together is 56. Therefore, the total, not changed, is still 56. So the mu, again, is the total over 20. So mu, I just put mu new. 56 over 20, that is 28. So the mu is still the same. I just keep it as mu new. So that 28 degrees C. But then, okay, well, the sigma standard deviation, this formula, standard formula, is square root of the total the values. So sigma I 1 to 20 xi squared, different divided by n minus mu 2. This is standard formula, which can be proved, but we don't need to prove that this is a standard formula can be used. So the sigma given in that question is 4. So when we actually square both sides, this is sigma squared, that is 4 squared, equals sigma I to 20 xi squared over 20 minus 28 squared. From that, we can find the sigma I to 20 xi squared equal, if we just work out some algebra, just 20 times 28 squared, bring it to this side, and 20 times 4 squared plus 28 squared. When you work it out, sigma I to 20 xi squared equal 16,000. 16,000 it worked out. Right, that's the value for standard deviation. When we actually calculate from the standard deviation, we actually got that xi squared is 16,000, sorry. But the new one, we have the two values. So that what this one is, xi squared. So just each day, square of that temperature, square of the temperature. First day, square that temperature. Second day, third day, and fourth day, add together is 16,000. But we have two incorrect values, which were 35 and 21. So just from the 16,000, 35 and 21, 35 squared and 21 squared removed. But then again at 25 squared, the new value, 25 squared and 31 squared. That gives us the new sigma I to 20 xi squared. So when you work it out, it will be instead of 16,000, now it's 15,920. So obviously it changed because of the incorrect change. It's going to change the standard deviation. So 15,920. What I did is I'll go through it again. 16,000 is the total value, xi squared, sigma, the total of xi squared. We have removed the errors day is 35 squared and 21 squared, and then add the correct one, 25 squared and 31 squared. This gives us the new sigma I to 20 xi squared is 15,920. Standard deviation, we know that standard deviation square root of the sigma I to 20 xi squared, that is new, I just put new in bracket, over n, and mu squared, again mu new, but even though it's mu new and mu old are same, but I just wanted to keep it as new so that we can understand properly. So sigma, the standard deviation, square root of 15,920, which we have found here, is 15,920 divided by 20 minus 20 squared. Then the rest is calculated. So the standard deviation is reduced a bit, 3.46. Before 4, now 3.46 degrees C. That's the last, what is it? Yeah, the mu is 28, standard deviation, new standard deviation 3.46. Thank you. Please subscribe the channel and share the contents with your friends and fellow students. Thank you.